Today we will discuss the hyperbola topic. Now, if suppose the hyperbola equation, standard equation of the hyperbola x square by a square minus y square by b square equals to 1. The standard equation of the hyperbola x square by a square minus y square by b square equals to 1. Now, x axis, y axis, the hyperbola. Now, for the hyperbola x square by a square minus y square by b square equals to 1, x axis is called transverse axis. And y axis is called conjugate axis. Conjugate axis. Now the point of intersection of transverse and conjugate axis is called center. Now see the center. The points of intersection of hyperbola and transverse axis, A and A dash are called vertices. S and S dash are foci. These two lines are directrices. Now, Z and Z dash are feet of the directrices. Z and Z dash are feet of the directrices. Now, if suppose a line or a chord passing through focus and perpendicular to axis is called latus rectum. L dash is one latus rectum. Similarly, second latus rectum L dash 1, L1. Now, one focus is AE comma 0, second focus minus AE comma 0. Foot of the directrix, one foot of the directrix Z coordinates A by E comma 0, Z dash coordinates minus A by E comma 0. And equations of directrices, one equation of the directrix x equals to A by E, second equation of the directrix x equals to minus A by E, or x equals to plus or minus A by E are equations of directrices. Next, equation of transverse axis, it is nothing but x axis equation y equals to 0. Similarly, conjugate axis equation x equals to 0. Now, the hyperbola equation x square by a square minus y square by b square equals to 1. X square by a square minus y square by b square equals to 1. Now, eccentricity of the hyperbola E equals to square root of a square plus b square by a square. If a greater than b, b greater than a, no change. Only eccentricity E equals to square root of a square plus b square by a square. Now, next, if suppose x axis, y axis, the hyperbola. For the hyperbola x square by a square minus y square by b square equals to 1, x axis is transverse axis, and y axis conjugate axis. If suppose for another hyperbola, x axis is conjugate axis, y axis transverse axis, then this hyperbola is called conjugate hyperbola of the given hyperbola. Now, these two hyperbolas are called conjugate hyperbolas. Now, equation of conjugate hyperbola is x square by a square minus y square by b square equals to minus 1. Equation of conjugate hyperbola is x square by a square minus y square by b square equals to minus 1. Hyperbola equation x square by a square minus y square by b square equals 1, and its conjugate hyperbola equation x square by a square minus y square by b square equals to minus 1. Now, eccentricity of the conjugate hyperbola, if suppose consider it is E dash, eccentricity of the conjugate hyperbola equals to square root of a square plus b square by b square. For a hyperbola, here denominator a square, eccentricity E equals to square root of a square plus b square by a square. For conjugate hyperbola eccentricity, square root of a square plus b square by b square. Now, if suppose E and E dash are eccentricities of a hyperbola and its conjugate, then we get 1 by E square plus 1 by E dash square equals to, now square and reciprocal, after that add both, we get a square by a square plus b square by a square plus b square, that equals to, we get 1. Now, if suppose E and E dash are eccentricity of a hyperbola and its conjugate, then always 1 by E square plus 1 by E dash square equals to 1. 1 by E square plus 1 by E dash square equals to 1. Next, if suppose hyperbola equation x square by a square minus y square by b square equals to 1. If y equals to mx plus c, if y equals to mx plus c is a tangent to the hyperbola x square by a square minus y square by b square equals to 1, then the condition c square equals to a square m square minus b square. If c square equals to a square m square minus b square, then the line y equals mx plus c is a tangent to the hyperbola x square by a square minus y square by b square equals to 1, and point of contact minus a square m by c comma minus b square by c. Point of contact minus a square m by c comma minus b square by c is the point of contact. And if suppose Lx plus my plus n equals to 0 is a tangent to the hyperbola x square by a square minus y square by b square equals to 1, then the condition is a square l square minus b square m square equals to n square. If Lx plus my plus n equals to 0 is a tangent to the hyperbola x square by a square minus y square by b square equals to 1, the condition is a square l square minus b square m square equals to n square, and point of contact minus a square l by n comma b square m by n is the point of contact. Minus a square l by n comma b square m by n is the point of contact. If suppose the hyperbola equation x square by a square minus y square by b square equals to 1, p x1 y1 lies outside of the hyperbola. P x1 y1 lies outside of the hyperbola. First of all, if suppose the hyperbola equation x square by a square minus y square by b square minus 1 equals to 0, consider it is s equals to 0. S equals to 0. Now, center C 0 comma 0. Now 0 comma 0 lies outside of the hyperbola. Lies outside of the hyperbola. Origin lies outside of the hyperbola. Now, taking the point 0 comma 0 as x1 y1. Now, if s11 means substituting the point 0 minus 1, that equals to minus 1, it is less than 0. Less than 0. Now, in circle or parabola or ellipse, if s11 less than 0, the point lies inside of the curve. But here s11 less than 0, the point lies outside. If s11 equals to 0, the point lies on the hyperbola. S11 greater than 0, the point lies inside of the hyperbola. If suppose the point p x1 y1 lies outside of the hyperbola, from external point two tangents can be drawn to the hyperbola. Two tangents can be drawn. Slope of one tangent consider m, then equation of the tangent in the slope form y equals to mx plus square root of a square m square minus b square, because c square equals to a square m square minus b square. Now c equals to plus or minus square root of a square m square minus b square. But that tangent passing through x1 y1, then y1 equals to mx1 plus square root of a square m square minus b square. Y1 equals mx1 plus square root of a square m square minus b square. Now mx1 take left side, and after that squaring on both sides, y1 square plus m square x1 square minus 2m x1 y1 equals to a square m square minus b square. Now in m square x1 square, a square m square common, x1 square minus a square into m square minus 2 x1 y1 m plus y1 square plus b square equals to 0. Now it is a quadratic equation in terms of m. It is a quadratic equation in terms of m. It having two roots. That roots consider m1 and m2. m1 and m2. Now m1 and m2 are slopes of two tangents passing through a fixed point px1 by 1. Passing through fixed point px1 by 1. Now sum of slopes or sum of roots of this equation equals to 2x1 by 1 by x1 square minus a square. Product of roots or product of slopes equals to m1 m2 equals to y1 square plus b square by x1 square minus a square. Sum of slopes equals to 2x1 y1 by x1 square minus a square, and product of slopes equals to y1 square plus b square by x1 square minus a square. Now if these tangents are perpendicular to each other, then product of slopes equals to minus 1. Now y1 square plus b square by x1 square minus a square equals to minus 1. By cross multiplication, y1 square plus b square equals to minus x1 square plus a square. Now x1 square plus y1 square equals to a square minus b square. x1 square plus y1 square equals to a square minus b square. Now locus of x1 y1 is x square plus y square equals to a square minus b square. Now it is a circle. Concentric with the given hyperbola. Now this circle is called directed circle. Of the given hyperbola. Means the locus of point of intersection of perpendicular tangents to a hyperbola is a circle. Then this circle is called directed circle of the given hyperbola. If suppose the hyperbola equation x square by a square minus y square by b square equals to 1, px1 by 1 is a point. Now equation of the tangent at the point px1 by 1 is s1 equals to 0, or xx1 by a square minus y1 by b square equals to 1, s1 equals to 0. Now similarly equation of the normal at x1 by 1 is a square x by x1 plus b square y by y1 equals to a square plus b square. It is equation of the normal at x1 by 1. Equation of the normal at x1 by 1 to the hyperbola x square by s square minus y square by b square equals to 1. Now the parametric equations of the hyperbola x square by a square minus y square by b square equals to 1, or x equals to a secant theta, y equals to b tan theta. X equals to a secant theta, y equals to b tan theta are called parametric equations of the hyperbola x square by a square minus y square by b square equals 1. Here at the point theta means a secant theta, b tan theta. Now equation of the tangent at the point theta or at a secant theta, b tan theta is x by a secant theta minus y by b tan theta equals to 1. Now it is equation of the tangent at theta. Now equation of the normal at the point theta is ax by secant theta plus by by tan theta equals to a square plus b square. Equation of the normal at the point theta. Normal at the point theta is ax by secant theta plus by by tan theta equals to a square plus b square. Asymptotes. Next to asymptotes. If suppose hyperbola, take the standard equation x square by a square, hyperbola equation x square by a square minus y square by b square equals to 1. If suppose tangents from infinite and passing through center of the hyperbola are called asymptotes of the hyperbola. These two are asymptotes. Now passing through center, but for standard hyperbola x square by a square minus y square by b square equals to 1, center is 0, 0. Now consider slope of asymptote is m. Let m be the slope of asymptote. Now equation of the tangent with slope m is y equals to mx plus square root of a square m square minus b square. But it passes through center 0, 0. Then constant must be equals to 0. Constant equals to 0. Now a square m square minus b square equals to 0. We get m equals to plus or minus b by a. M equals to plus or minus b by a. Now m equals to plus or minus b by a. Substituting in the equation. Now y equals to plus or minus b by a into x. Now the asymptotes of the hyperbola y equals to plus or minus b by a into x, or x by a minus y by b equals to 0. One asymptote. Second asymptote x by a plus y by b equals to 0. Now the equations of asymptotes of the hyperbola x by a minus y by b equals to 0 and x by a plus y by b equals to 0. Now combined equation of asymptotes is x square by a square minus y square by b square equals to 0. Just multiplying together we get combined equation of asymptotes. Now combined equation of asymptotes nothing but x square by a square minus y square by b square equals to 0. Now always the equation of the hyperbola and equation of its asymptotes only differ by constant. Now hyperbola equation and its asymptotes equation differ by constant. Now one asymptote equation x by a minus y by b equals to 0. Second asymptote x by a plus y by b equals to 0. If suppose consider the angle between the asymptotes is theta. Angle between the asymptotes of the hyperbola consider theta, then semi-angle equals to theta by 2. Semi-angle equals to theta by 2. Now a straight line inclined an angle theta with x-axis in the positive direction, its slope equals to tan theta. But here asymptote makes an angle theta by 2 with x-axis in the positive direction, then its slope equals to tan theta by 2. But tan theta by 2 equals to slope of the asymptote x by a minus y by b equals to 0. Now slope of the line x by a minus y by b equals to 0 is b by a. Now theta by 2 equals to tan inverse b by a. Theta by 2 equals to tan inverse b by a. Then theta equals to 2 tan inverse b by a. Now if angle between the asymptotes of the hyperbola x square by a square minus y square by b square equals to 1 is theta, then theta equals to 2 tan inverse b by a. Theta equals to 2 tan inverse b by a. Similarly, if suppose here tan theta by 2 equals to b by a, secant square theta by 2 equals to 1 plus tan square theta by 2, or that equals to 1 plus tan theta by 2 equals to b by a tan square theta by 2 b square by a square, or that equals to a square plus b square by a square. It is nothing but e square. Now secant theta by 2 equals to e, for implies theta by 2 equals to secant inverse e. Now angle between the asymptotes theta equals to 2 secant inverse e. Now angle between the asymptotes in terms of a and b is theta equals to 2 tan inverse b by a, and e is the eccentricity. Angle between the asymptotes theta equals to 2 secant inverse e. 2 secant inverse e. If suppose the angle between the asymptotes theta equals to 90 degrees, theta equals to 90 degrees. Now theta by 2 equals to 45. 45 degrees equals to tan inverse b by a. Now in this case we get a equals to b. Tan 45 equals to 1, 1 equals to b by a, or a equals to b. Now if angle between the asymptotes of a hyperbola is 90 degrees, then a equals to b. If angle between the asymptotes is 90 degrees, then the hyperbola is called rectangular hyperbola. rectangular hyperbola. If angle between the asymptotes of a hyperbola is 90 degrees, then the hyperbola is called rectangular hyperbola. In that case, A equals to B. Now, eccentricity E equals to square root of A square plus B square by A square. But for rectangular hyperbola, A and B both are equal. A equals to B. Now, at place of B equals to A, substitute square root of A square plus A square by A square, or that equals to, we get root 2. Now, always eccentricity of the rectangular hyperbola, equals to root 2. Rectangular hyperbola eccentricity root 2. Suppose the hyperbola. Now, transverse and conjugate axis are not coordinate axis. In that case, the hyperbola equation, just second degree general equation, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. Consider the equation of the hyperbola s equals to 0, or second degree general equation in terms of x and y. Now, the equation of asymptotes of the hyperbola and hyperbola equation differ by only constant k. Now, s equals to ax square plus 2hxy plus by square plus 2gx plus 2fy plus k equals to 0. Now, the asymptotes equation in the form of ax square plus 2hxy plus by square plus 2gx plus 2fy plus k equals to 0. But here asymptotes are nothing but two straight lines or a pair of straight lines. If angle between the asymptotes of the hyperbola, if suppose general equation given is theta, then cos theta equals to a plus b by square root of a minus b whole square plus 4h square. Cos theta equals to a plus b by square root of a minus b whole square plus 4h square. Now, if suppose theta equals to 90 degrees, then cos 90 0, then we get a plus b equals to 0. Now, coefficient of x square plus coefficient of y square equals to 0. Then angle between asymptotes of the hyperbola is 90 degrees. Angle between asymptotes of the hyperbola is 90 degrees. If suppose the hyperbola equation, consider h equals to 0, or x square by a square minus y square by b square minus 1 equals to 0 or equals to 1. Hyperbola equation h equals to 0, and its conjugate hyperbola equation x square by a square minus y square by b square plus 1 equals to 0 or equals to minus 1. And asymptotes equation, consider a. Asymptotes equation x square by a square minus y square by b square equals to 0. Now, hyperbola equation h equals to 0, conjugate hyperbola equation c equals to 0, asymptotes equation a equals to 0, then always h plus c equals to 2a. Now, the sum of equations of a hyperbola and its conjugate hyperbola equals to 2 times to its asymptotes equation, 2 times to their asymptotes equation. Next, we can do some problems on the hyperbola. First problem, the vertices of a hyperbola 2, 0, minus 2, 0, and the foci are 3, 0, minus 3, 0, 3, 0, minus 3, 0. Vertices 2, 0, minus 2, 0, foci s and s dash 3, 0, minus 3, 0. The equation of the hyperbola, required equation of the hyperbola. Now, always vertices of the hyperbola a, 0, minus a, 0. Both points lie on the x-axis. Now, x-axis is transverse axis. Now, foci of the hyperbola ae, 0, minus ae, 0. Now, equating, now we get a equals to 2, ae equals to 3. A equals to 2, a equals to 3. Now, b square equals to a square e square minus a square, or a square into e square minus 1, a square into e square minus 1, or a square e square minus a square. Now a equals to 3, a square equals to 2. Now a square e square 9, a square equals to 4. Now b square equals to 5. The required equation of the hyperbola x square by a square minus y square by b square equals to 1. Now substituting the values, we get x square by 4 minus y square by 5 equals to 1. It is the required equation of the hyperbola. Then second option is the correct. The center of the hyperbola 9x square minus 16y square plus 72x minus 32y minus 16 equals to 0. Minus 16 equals to 0. If suppose the equation converted in the form of x minus h whole square by a square minus y minus k whole square by b square equals to 1, then h comma k is the center. H comma k is center of the hyperbola. But the given equation converted in the form of x minus h whole square by a square minus y minus k whole square by b square equals 1. That is very lengthy process. Now finding center, the given equation of the hyperbola, consider s equals to 0. Now differentiate partially with respect to x. Now dou s by dou x equals to 18x plus 72 equals to 0. Now similarly, the given equation differentiate with respect to y. Dou s by dou y equals to minus 32y minus 32 equals to 0. Just solve these two equations, we get center. Solve two equations, we get center. Now 18x equals to minus 72, x equals to minus 4, x equals to minus 4. Similarly, y equals to minus 1. Then center minus 4 comma minus 1. Fourth option is the correct. The foci of the hyperbola x minus 2 whole square by 16 minus y plus 3 whole square by 9 equals to 1 are required the foci of the hyperbola. Here center h comma k equals to 2 comma minus 3. H comma k equals to 2 comma minus 3. Then the foci of the hyperbola, it is a hyperbola. Now h plus or minus ae comma k, h plus or minus ae comma k are the foci. One focus h plus ae comma k, second focus h minus ae comma k. Now ae equals to square root of a square plus b square, or e equals to square root of a square plus b square by a square. By cross multiplication, a equals to square root of a square plus b square. Now here a square value is 16, b square equals to 9. Now a equals to, we get 5. Then foci equals to 2 plus or minus 5 comma minus 3. 2 plus or minus 5 comma minus 3 are foci. Now third option is the correct. The length of the latus rectum of the hyperbola x square minus 4y square equals to 4. X square minus 4y square equals to 4. Now the given equation converted in the standard form, x square by 4 minus y square by 1 equals to 1. Now a square equals to 4, b square equals to 1. Now length of the latus rectum equals to 2b square by a. Length of the latus rectum equals to 2b square by a. Now that equals to 2 into, here b square equals to 1, a square equals to 4, then a equals to 2. 2 by 2, that equals to 1. Then length of the latus rectum of the given hyperbola is 1. Then second option is correct. The eccentricity of the hyperbola 9x square minus 16y square equals to 144. The eccentricity of the hyperbola 9x square minus 16y square equals to 144. Now, here directly the coefficient of y square take as a square, coefficient of x square b square. Now, E equals to square root of a square plus b square by a square, or that equals to square root of, here a square nothing but coefficient of y square 16, b square is coefficient of x square by 16, or that equals to 5 by 4. Eccentricity of the given hyperbola 5 by 4, second option. If E and E dash are eccentricities of the hyperbola x square by a square minus y square by b square equals to 1 and its conjugate hyperbola, then the value of 1 by e square plus 1 by e dash square equals to, now hyperbola equation x square by a square minus y square by b square equals 1 and its conjugate hyperbola x square by a square minus y square by b square equals to minus 1. Conjugate hyperbola equation x square by a square minus y square by b square equals to minus 1. Now, eccentricity of the hyperbola E equals to square root of a square plus b square by a square, and conjugate hyperbola eccentricity E dash equals to square root of a square plus b square by b square. Now, require the value 1 by e square plus 1 by e dash square, substituting values. Now, a square by a square plus b square by a square plus b square. Now, that equals to 1. 1 by e square plus 1 by e dash square equals to 1. Third option is correct. If the latus rectum of the hyperbola through one focus subtends 60 degrees at the other focus, then its eccentricity. The hyperbola. One focus S. L dash, consider one latus rectum passing through focus S. Second focus S dash. But latus rectum passing through one focus subtend an angle 60 degrees at second focus at another focus. Now, required eccentricity of the hyperbola. Now, here transverse axis is angular bisector of angle S dash. Now, semi angle equals to 30 degrees. Now, always the distance between foci S and S dash equals to 2AE. The distance between foci SS dash equals to 2AE. Next, length of the semi-latus rectum SL equals to B square by A. Length of the semi-latus rectum SL equals to B square by A. Now, in triangle S dash S and L, angle AC equals to 90. Angle S dash equals to 30 degrees. Now, in triangle S dash SL, tan 30 degrees equals to SL by SS dash. Now, tan 30 value 1 by root 3 equals to SL equals to length of the semi-latus rectum B square by A by SS dash equals to 2AE. Now, 1 by root 3 equals to B square by 2A square E. 2A into A square E. But B square value in a hyperbola A square into E square minus 1 by 2A square E. Now, A square cancel, by cross multiplication we get 2E equals to root 3 E square minus root 3, or root 3 E square minus 2E minus root 3 equals to 0. Root 3 E square minus 2E minus root 3 equals to 0. Now, by factorization we get root 3 E square minus 3E plus E minus root 3 equals to 0. Now, in first two terms root 3E common, e minus root 3. Next plus 1 common, e minus root 3 equals to 0. Now we get e equals to root 3 or minus 1 by root 3. But eccentricity is a ratio. Ratio always positive. Then 1 by root 3 minus 1 by root 3 impossible. Then e equals to the eccentricity of the given hyperbola e equals to root 3. Then second option is correct. Second option. Let L dash with the latus rectum through the focus S of the hyperbola, A dash with the farther vertex of the conic. If triangle A dash L dash, A dash L dash is an equilateral, then its eccentricity, Now take the hyperbola. If suppose A and A dash are vertices, S1 focus, L dash, consider latus rectum which passes through the focus S. Now A is nearer vertex, A dash is farther vertex. But in problem given triangle A dash L dash, A dash L dash is an equilateral. Triangle A dash L dash is an equilateral. Now required eccentricity of the hyperbola. Triangle A dash L dash is an equilateral triangle. Now each angle equals to 60 degrees. Each angle equals to 60 in equilateral triangle. Each angle equals to 60. Now semi angle equals to 30 degrees. Let C be the center. Let C be the center of the hyperbola. Now always distance between vertex and center equals to A. Now A dash C equals to A. Similarly, the distance between center and one focus equals to AE. Center and one focus equals AE. Therefore, the distance between A dash S, equals to A plus AE. Next, SL equals to length of the semi-latus rectum, that equals to B square by A. SL equals to B square by A. Now in triangle A dash SL, angle S equals to 90, angle A dash equals to 30 degrees. Now tan 30 equals to opposite side by adjacent side, SL by A dash S. But tan 30 degrees value 1 by root 3 equals to SL equals to B square by A dash S equals to A plus AE. Or 1 by root 3 equals to B square by, first A common, A into A square into 1 plus E. Now 1 by root 3 equals to, but B square value in terms of A and E equals to A square into E square minus 1 by A square into 1 plus E. A square get cancelled. Now in numerator A square minus E square minus 1 by 1 plus E. Now here factors of E square minus 1, E plus 1 into E minus 1, but E plus 1 get cancelled. Then we get 1 by root 3 equals to E minus 1. For implies E equals to 1 plus 1 by root 3, or take LCM, we get root 3 plus 1 by root 3. Now the required eccentricity of the hyperbola equals to root 3 plus 1 by root 3, fourth option. The eccentricity of the hyperbola x equals to a by 2 into t plus 1 by t, comma y equals to a by 2 into t minus 1 by t. Y equals to a by 2 into t minus 1 by t. Now from these two equations eliminate t, we get the required hyperbola equation. Now if suppose x square minus y square equals to a square by 4, take common, we get t plus 1 by t whole square minus t minus 1 by t whole square. Now x square minus y square equals to a square by 4 into t plus 1 by t whole square minus t minus 1 by t whole square. It is in the form of a plus b whole square minus a minus b whole square. A plus b whole square minus a minus b whole square equals to 4ab. Now 4t into 1 by t. Now t get cancel, 4 also cancel. Now x square minus y square equals to a square. X square minus y square equals to a square. Then it is a rectangular hyperbola. Then eccentricity of the rectangular hyperbola always equals to root 2, because the sum of coefficients of x square and y square equals to 0. Then it is a rectangular hyperbola. Then eccentricity equals to root 2. Second option is correct. Second option. The locus of the point e power t plus e power minus t by 2, comma e power t minus e power minus t by 2 is a hyperbola of eccentricity. Now here consider x equals to e power t plus e power minus t by 2, y equals to e power t minus e power minus t by 2. From these two equations eliminate to t. From these two equations eliminate to t, we get equation of the hyperbola. After that we can find eccentricity. Now here x equals to e power t plus e power minus t by 2. It is nothing but cos ht. Similarly y equals to sin ht in hyperbolic functions. Now x square minus y square equals to cos h square t minus sin h square t. But cos h square t minus sin h square t equals to 1. Now x square minus y square equals to 1. Now it is also rectangular hyperbola. Then its eccentricity equals to root 2. Eccentricity equals to root 2. Now x square minus y square equals to 1. It is a rectangular hyperbola. Third option is correct. The sum and product of slopes of the tangents to the hyperbola 2x square minus 3y square equals to 6. 2x square minus 3y square equals to 6, drawn from the point minus 1 comma 1 or. Now the given hyperbola x square by 3 minus y square by 2 equals to 1. The given point consider x1 by 1. x1 by 1 equals to minus 1 comma 1. A square equals to 3, b square equals to 2. Now sum of slopes m1 plus m2 equals to 2x1 y1 by x1 square minus a square. 2x1 y1 by x1 square minus a square. Now 2 into here x1 minus 1 y1 1 by x1 square minus 1 square 1 minus a square minus 3, that equals to minus 2 by minus 2, or that equals to 1. Sum of slopes equals to 1. Next to required product of slopes. M1 M2 equals to y1 square plus b square by x1 square minus a square. Product of slopes equals to y1 square plus b square by x1 square minus a square. Now y1 square 1 plus b square equals to 2 by x1 square minus a square. x1 square 1 minus a square 3, or that equals to minus 3 by 2. Now sum of slopes equals to 1, product of slopes equals to minus 3 by 2. Then second option is correct. Second option.